Newton's first law. Now, Newton 1 was actually first discovered by Galileo, or scientifically discovered by Galileo. And later on, Newton went on to use that idea to formalize his own In Principia Mathematica. And this is, I think, where Newton's sort of saying about "I soar so far, for I stood on the shoulders of giants," or something thereabout, comes from, is that he took the ideas that Galileo had come up with and formalized them. So let's look at the definition. An object continues in a state of rest or a uniform velocity unless acted upon by a net or resultant force. So what do I mean by this? Basically, if an object's standing still or moving, it's going to continue standing still or moving unless we do something to it. So let's look at these examples. Firstly, we have our little block. This block has no forces acting on it, and it has a velocity of 0 meters per second. Therefore, it's going to continue at 0 meters per second. We could also add forces to this. So if we have a negative 3 going to the left, a positive 3 going to the right. If we add these two up, they're going to add up to 0. And so that tells us then that the object isn't going to move because there is no net or resultant force. We could also look at an object moving at a constant velocity, no forces acting on it, it continues moving at its constant velocity. Or, if we have another that has forces acting, but they're equal in the opposite directions, that means there is still no net or resultant force, and it moves at a constant velocity. Newton 2. The definition of Newton 2. When a net force, or F net, is applied to an object of mass, m, it accelerates in the direction of that net force. Then, the acceleration a is directly proportional to the net force and inversely proportional to the mass. So each of these can be shown by a little thing over here. The first section is shown by the general equation. If we have an object of mass, if a force is applied to an object of mass, it will accelerate in the direction of that force. Then, the next part is that there, where the acceleration is directly proportional to net force, that section, and inversely proportional to the mass, that section. Right, let's look at a little animation of this. So we're going to have 3 blocks. Each block is going to have an increasing amount of force acting on it. So block A has 2 newtons of force, block B has 3 newtons, and block C has 4 newtons. Right, if we line them all up together and let them go all at the same time, let's look what the result then would be. So, initially we get them going. We can already see here that the yellow one has taken the lead. That is simply because it had more force and so accelerates at a greater rate. We then see the green, which had the next most, and then the blue takes the longest. We can also look at it at increasing masses. So we've got 3 of them, each say 2 kilograms, 3 kilograms, 4 kilograms, but now all of them have the same amount of force. So which one do you think would be able to accelerate at the quicker rate? If you look at this equation, obviously we see that the yellow one will go quicker, then red, and green will accelerate at the slowest rate because it has the greatest amount of mass. And then the third law. So, the third law's definition. When object A exerts a force on object B, as that thunder just did, object B simultaneously exerts an oppositely directed force of equal magnitude on object A. Simply said, this one is best known as, for every action, there is an equal and opposite reaction. So let's look at our little animation now. We've got object A and object B. Object A is going to have a force applied to it, and we're going to see what the result of that will be. So, we apply our force A onto object B. Now what we can see at this point is A is applying a force forward to object B, and object B is going to apply a force back onto object A. If we increase the force of A, it'll increase the force of B. But both of them are going to push on each other with exactly the same amount of force as the definition says. And so it'll then continue moving in the direction of whatever the net force is. As we can see, this force is greater than these two forces combined, and so it will not accelerate. The other thing we can look at is the acceleration of A will be greater than the acceleration of A and B. And that's simply because that force stays the same, and if we go back to Newton 2, more mass means less acceleration. So less mass, more acceleration, more mass, less acceleration.